Hey guys, today we're going to do 4-8 complex numbers part 2. We are going to graph complex numbers, we are going to factor with complex numbers, and we are going to find complex number solutions of quadratic equations. So first, in the complex number plane, the point AB represents the complex number A plus BI. So we are going to have a coordinate plane. Instead of XY axis, it's going to be a real axis and the imaginary axis. So this is our real axis and this is our imaginary axis. And so we're going to graph the real part on the horizontal axis and the imaginary part on the vertical axis. And then to find the absolute value of a complex number, we are going to use the formula absolute value of A plus BI equals the square root of A squared plus B squared. And this is really the distance from the origin, or in the complex plane, because absolute value is distance to 0. That's why we're going to use the distance formula. What are the graph and the absolute value of each number? So we have -5 plus 3i. So if we're looking at our imaginary plane, I'm going to go -5, 3. So I'm going to go left 5, up 3. And that is the point, -5, 3 plus 3i. In order to find the absolute value of -5 plus 3i is equal to the square root of -5 squared plus 3 squared. And that is 25 plus 9, which is the square root of 34. Now, powers of I. We know that I is equal to the square root of -1. We know that I squared is -1. So now I cubed is I times I squared, which is negative square root of -1. The I to the 4th power is now going to be I to the 3rd times, or I squared times I squared to make it more simple, which is just 1. And now I to the 5th is now going to be I to the 4th times I, which is square root of -1. So there's a cycle here, repeating with these 4 as a pattern. If I want to find what I to the 25th power is, I'm going to move that up here so we could look at the 4 powers. That means it would be 1, 2, 3, 4, 5, 6, 7, 8, repeating until we get to 24. The reason we want to know 24 is because that's the closest number that 4 can go into, which means we would go end at I to the 4th at 24. Then 25 would be here, which is equal to the square root of -1. So I to the 25th power is equal to the square root of -1. Factoring using complex conjugates. Whenever we're factoring, we have to take out our GCF first. So 2 times x squared plus 16. Now, x squared plus 16 is where the complex conjugate comes in. Because x squared plus 16 is a sum of squares, and sum of squares is going to be, we can use the square root of the first and the square root of the second, I. So we would do x plus 4i times x minus 4i. Bring down my GCF. So that's going to cancel out my middle term, and it's going to make my last term positive. To double check, you could FOIL. You would do x times x, which is x squared. my 4x i's cancel. Whenever I have I squared, I change it to positive, and we are left with x squared plus 16. So my factored form would be 2 times x plus 4i times x minus 4i. Finding imaginary solutions. What are the solutions of 2x squared minus 3x plus 5 equals 0? I first check a GCF. I don't have one. Then I would think, what can I multiply to positive 10? Add to negative 3. Does not work. So I'm going to use my quadratic formula. X is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. A is equal to 2, b is equal to negative 3, c is equal to 5. Plug in. X is equal to 3 plus or minus the square root of 9 minus 4 times 2 times 5 all over 2 times 2. Evaluate. X is equal to 3 plus or minus the square root. 8 times 5 is 49 minus 40 over 4. X is equal to 3 plus or minus the square root of negative 31 over 4. And since I have a negative in my square root, I know my solution is going to be imaginary. So 3 plus or minus I root 31 over 4. And now I can split it up. So x would be equal to 3/4 plus I root 31 over 4, or x is equal to 3/4 minus I root 31 over 4, would be my two imaginary solutions.